to take a topic where you don't know anything. So about complex number, you don't know anything, right?
Yes.
Yeah. So I'll be taking complex number. Let's take it. And for the first 30 minutes, we'll be having the discussion related to this concept from the basic. And for the next 30 minutes, we'll be having one diagnostic assessment. So actually that assessment will contain questions from class 9, class 10, which is required in class 11. Okay, the topics which needs to be clear. So we are just getting familiar with our student. If anywhere we will feel that extra classes are required just to polish the concept, just one extra class. So we'll be arranging accordingly. Okay, so for that reason only we are having that diagnostic assessment. Okay, Abdul.
Yes, teacher.
So yeah, let's start the discussion. First, we are going to discuss the topic that is complex number. So if we are having, you have learned a chapter quadratic equation in the previous class, right?
Yes, teacher.
Okay, in quadratic equation, can you recall there were three rules for finding the nature of the root? When I'll write the equation that is x square plus 1 is equals to 0, is it quadratic equation, Abdul?
No, teacher.
Okay, it's not quadratic. See, the highest power of the variable over here is 2. Maximum power of x is 2. That means it is quadratic, right?
Yes.
Okay, if you can recall, but quadratic equation looks like this: 2x square plus 5x plus 7 is equals to 0, right?
Yes, teacher.
Okay, so yeah, this is also quadratic and this is also quadratic. Okay, it's completely okay not to have this x terms. Okay, here we don't have the equation which I have written at first. Here you don't have any x term, and that is completely fine. One and only one definition of quadratic equation was that the highest power of the variable needs to be 2. So if you are having just x square plus 1 is equals to 0, that is quadratic. Or in case you are having just x square is equals to 9, that is also quadratic, because it is fulfilling that the highest power of the variable is 2 over here. Making sense?
Yes, teacher.
Okay, so I am taking quadratic equation which you have learned in the previous class. Now you must have learned there were three rules to check the nature of the roots, right?
Okay.
So discriminant you were finding over there. Can you recall discriminant you were finding while checking the nature of the root? That is b square minus 4ac.
Yes, teacher.
If that is bigger than 0, then roots are real and distinct. Distinct means both the roots are different from each other, right? If b square minus 4ac is equals to 0, then roots are real and same, right?
Yeah, I joined with another device. Can you let that in?
Yeah, sure. Take your time. Can you hear me? Can you hear me, Abdul?
Yes, teacher, I can hear.
Okay, and the third rule over there was if b square minus 4ac is smaller than 0, then roots are not real. Can you recall? Yes, Abdul, can you recall these three rules from there?
Yes, teacher, I can remember.
Okay, you must have checked what is a, what is b, what is c. For example, if I have written the second example, that is 2x square plus 5x plus 7 is equals to 0. Can you tell me what is a, what is b, what is c over here?
Yes. 2x, b is 5x, and c is 7.
Okay, a is the coefficient of x square. Okay, Abdul, a
Yes.
is the coefficient of x square. The standard form of the quadratic equation is ax square plus bx plus c is equals to 0, where a is whatever multiplied with x square, that is our a. So here a is just 2, positive 2.
Okay.
Getting it? And b is positive 5. C is positive 7. Okay, if I'll take another example, let's say I'm taking minus 5x square minus 3x plus 30 is equals to 0. First of all, is it a quadratic? This is quadratic equation, Abdul.
Yes, yes, yes.
Yeah, it is. What is A? What is B? What is C?
Minus 5 is a, minus 3 is b, and 30 is c.
Perfect. So this is how you have. Okay, you used to take out A, B, C when you were in the previous class, and you must have checking. Uh, you must be using these rules. Number one says just check B square minus 4AC. Okay, just check b square minus 4ac. So for this particular question, the circled one, if we will check b square minus 4ac, see, b value we are having in hand, a value we are having in hand, c value we are having in hand. We just need to do the calculation. Just a moment now. Just give me a moment.
Okay.
Yeah. So b square minus 4ac will be checking over here just to check the nature of the root. Okay. So b square here, b, just now you told me that b is minus 3. So I will drop this minus 3 at the place of b, and I'll do the squaring over here. Minus 4, I'll drop the a value over here, that is minus 5, and I'll drop the c value over here, that is 30. And what are we going to get? 3 square will be 9. Okay, and minus 3 square will be positive 9. Right, Abdul?
Yes, yes, yes.
And here we are going to get 5, 4 times 20. 20 into 30. Can I say it will be 600? Can I?
Yes,
Will
yes,
it
yes.
be 600? See, bottom says,
600 plus 9.
okay. Bottom says do the multiplication. So we have done the multiplication. We got this one. 600 plus 9 will be 609. Now, can we see 609? It's a positive number over here,
Yes, yes, yes.
which is bigger than 0. And the rule
Yes.
says, in case you have found b square minus 4ac, and in case you are, you can see that your b square minus 4ac is result that is positive. That means bigger than 0. Then the rule says the roots will be real. Real means real number. Roots will be real and distinct, right? Distinct means both the roots are different. That means after solving this quadratic equation, there are two x values possible over here, and both are different from each other, and also both are real number. Without even solving, this much idea we are getting how just how we see the people, and we say the person looks shy, or maybe the person looks very confident. Okay, that means we are talking about the nature of the person, right? Right,
Yes.
just by observing the face. Okay, similarly, just by observing this quadratic equation and using little bit, okay, doing little bit simplification using this rule of discriminant, we are able to say that here roots are real. That means real number will be getting the x value, and distinct, that means both the roots will be different from each other. Okay, not same. You must have seen such quadratic equation where both the roots, okay, will be same. Okay, where one of the x value is 2 and another is 2. Yeah, that is possible. Have you seen such quadratic equation?
I have seen maybe.
Okay, I can give you one example over here only, so that we can continue with the part 3, that what is imaginary. If real will be clear, then I'll be moving to the third part, because that is the motto of this chapter. So first, let me take this part first. If we are having a quadratic equation x square, suppose we are having 9 minus 6x is equals to 0. Let's solve this quadratic equation and let's check the x value. Do you know how to use this splitting the middle term, Abdul?
Yes, teacher.
Okay, can you do splitting the middle term over here?
Yes.
Yeah, please do it.
We split 9, right?
Yeah, 9.
3 into 3.
Yeah. So we are going to get x square minus 3x plus 9, right? From the first two term, we will take out common and it is x common x minus 3, right?
Yes.
And from the next two term, what is common, Abdul?
3.
Positive 3 or negative 3?
Positive.
Negative 3. Okay, because this minus 3, when you will take common, then only just like the first bracket, you will be able to get
Okay, okay, yeah.
only, yeah, only x over here, right? Right?
Yes, yes.
Okay, we try making both the brackets same, and since you have taken negative common, due to this negative, each and every sign will reverse. So you can see here x is remaining, that too positive. Previously it was negative, okay, minus 3x was there. X was attached with the negative number. Previously it was negative, but since we have taken negative out, this became positive. And which the number which is positive, that will be negative. Are you understanding?
Yes, yes.
Okay, since 3 you have taken common, that's why from 9 I am writing just 3 remaining. Clear?
Yes.
We always check these two brackets are exactly same or not. If these two brackets are exactly same, then only we can assure ourselves that yeah, we are on the right track, right?
Yes.
Okay, now one of the bracket is x minus 3, another bracket is x minus 3, and we were solving quadratic equation. So equals to 0 equals to 0, here also equals to 0. Now after this step, what we do, we just split, like we just take the first bracket is equals to 0, or maybe the second bracket is equals to 0, right, Abdul?
Yes, yes.
Can you see both the x value which we found over here and the x value which we found over there are same
Yes. Both the answers
and
are 3.
real, right?
Yes.
Okay, that's what the rule says, that if you don't want to do this much, and if you just want to just get the idea about the nature, that what can be the nature, what can be the nature of this quadratic equation. So for that reason only you have learned that there is a rule b square minus 4ac called as discriminant b. Just check this, do the calculation. So from this equation, if you will do the calculation, your a value is positive 1. Can you see, Abdul?
Okay, teacher.
Okay, because with x square, nothing is multiplied, 1 is there, right?
Yes.
Okay, we will
Okay,
not
yes.
say 0. We will not say 0. It is positive 1. Getting it?
Yes.
Okay. With for b, can you tell me what is b over here in this quadratic equation?
6.
Positive or negative?
Negative.
Negative 6. And what about C?
Positive 9.
Positive 9. So we are going to check the nature of the root b square minus 4ac. Our b value is minus 6 whole square minus 4ac. So 4 multiplied with our a value, that is 1, multiplied with our c value, that is 9. And Bodmer says first focus on the multiplication, right?
Yes.
Okay, so minus x square you can do, that will be just 36. Then we have to focus on the multiplication before doing subtraction and all. So 9 4 times 36. 36 minus 36 is 0. Our discriminant came out as a 0. And let me show you what I have written for rule number 2. Can you see the 3 rules, Abdul, over here?
Yes, teacher.
The first rule I have written that in case your b square minus 4ac is bigger than 0, then the roots are real and distinct. That means the roots will be real number and will be different from each other, right?
Yes.
The second rule I have written, if b square minus 4ac is equals to 0, then the roots are real number and same, right?
Yes.
Just now we have checked our b square minus 4ac calculation we have done, and we ended up getting 0. So we can say roots will be real and same. And separately, we have solved the quadratic equation also. And we have found that yes, roots are real number, that is 3, and are same with each other. Both the x values are 3, right?
Yes.
So this rule is making sense.
Yes, teacher.
Okay. So yeah, let me take the third situation. Just a second. Yeah. Now we are going to talk about the third scenario over here, because these all were there in your class 10, and I want to start from here. That what about the case when roots are not real? Okay, when your b square minus 4ac you are calculating and you are getting a negative number, then what you will do? What is that case? Okay, so do you know what is real number, Abdul?
Yes, teacher.
What is real number?
Real numbers are like normal numbers.
Yeah, all the numbers which exist in this universe are real number. Okay,
Yes.
any number you write, decimal, not decimal, okay, integer, not integer, natural, whole, any number I'll write on the screen, this is screen, and that will be a real number, right?
Yes, teacher.
Okay, so I am going to take a quadratic equation, that is x square plus 1 is equals to 0, and we don't want to solve it finding x value. We just want to check what is the nature of the root by finding the discriminant. Here, if you will observe carefully, x square coefficient is 1. So your a value is 1, positive 1, right?
Yes, teacher.
Now, when you will try finding b, then you need to realize that the standard form was ax square plus bx plus c is equals to 0. B is that term which is, okay, that number which is multiplied with x, and here we don't have such okay, x term we don't have over here in our equation, right? Can we see x in our example, x square plus 1 is equals to 0? Can you see x over here? Just
Yes.
x
Yes,
square,
yes.
not just x.
No, no.
Okay, so we will say b is 0, making sense.
Yes, teacher.
And c is 1, the constant number which is not multiplied with x square or x, which is just sitting separately. That is our c, just the constant. Making sense?
Yes.
Okay, so in this quadratic equation, a is 1, b is 0, c is 1. Clear?
Yes.
Now we will try finding b square minus 4ac. Our b value is 0, which is completely okay. Okay, 0 square minus 4 into a into c. Bodmer says do the multiplication properly. It will be minus 4. 0 square is just 0. 0 minus 4 will be minus 4. Okay, just minus 4 we are getting, and we can clearly see that our b square minus 4ac, the discriminant came out as a negative number, right? Discriminant is smaller than 0, right?
Yes.
When it is smaller than 0, then roots are not real. Okay, so there are such numbers which are not real, okay, which just came from the imagination of our mathematician. Okay, so real number, you understand that all the number which exist in this universe are real number. Now here we will be talking about imaginary number. Imaginary number, something which is completely new for you. Have you seen Avatar movie?
I've heard about it, but I haven't seen.
So such movie you must have seen where a creature is there, or something fictional creature is there. Start
Yeah, yeah,
just
yeah, I know.
creature is
The
eating
blue
the
color creature.
buildings, okay, and just doing randomly anything which doesn't exist in real world, right? But
Yes.
you believe it. The moment you are watching the movie, you enjoy it, just taking it as it is, right?
Yes.
Okay, here in this chapter, when we are talking about imaginary numbers, we will not try relating it with the real numbers and all for now. Okay, these concepts given by our mathematician completely came from the imagination of our mathematician. Okay, it was required, hence they have created the complete different branch of mathematics, and we will try learning it as it is. Okay, without every time trying connecting it with the real numbers and all. Making sense?
Okay.
So mathematician said that whenever you will be getting negative number inside the root, whenever you will be getting negative number inside the root, from here the imaginary, okay, numbers concept came in existence. They said that whenever you are having root minus 1, let's call it I, that is imaginary unit, or its name is iota. We also call it iota. Okay, whenever we are having,
Iota.
yeah, iota, whenever we are having under root minus 1, it is okay, the we can represent it with I. How you know? Pi means 22 by 7, right? Or maybe pi means approximately 3.14. These two are approximate value of pi, right?
Yes.
Similarly, today I am telling you that root minus 1 is I. Okay, I means imaginary unit or iota. Okay, now if we will be having, you first tell me, do you know that root 2 into root 3, Abdul, is root 6? Do you
Yes.
know? Yes. Okay, why? Because both the root numbers are collaborating with each other and they are discussing, let's come and sit inside the one root sign, and hence they are making this one, right?
Yes.
Okay, similarly, if we are having minus root 36, so we can break it also. The way you are adding them together, I can break it also. I can write it as a minus 1 into 36. And I can separate it that one of the root is containing minus 1, another root is containing 36. Is it making sense how I am breaking it?
Yes. You are adding minus one and making it 2.
Yeah, two terms. Okay, because
Yes.
negative 46 was there, so I can write minus 1. It is not making any
Yes. Yes.
difference. Okay, we are making it, okay, two terms, splitting it in two terms. Why? Because now I can say this root minus 1 is I and root 36 is 6, so it is You can write it I into 6, or you can write it 6I. Making sense?
Yes.
So from now onward, whenever you will be having negative number inside the root, doesn't matter that number is a perfect square number or not perfect square number. Anytime, anywhere you will see a negative number inside the root, that means it is imaginary. Okay, from here the complex
Okay.
number concept, from here the imaginary unit and iota concept came in consideration. We will be able to write it as a under root 2 into under root minus 1, which I am writing directly for now, and you can write it as a root 2I. Making sense?
Yes, teacher.
Let's take few more examples like this and you tell me how to write it. So suppose we are having let's say minus 25. Please simplify it and tell me what are we going to get in terms of I, the way I was showing you just now.
Teacher, can't hear you.
Can we write it as a root 25 into root minus 1? Yes, Abdul.
Hello. Can you hear me, teacher?
Yeah, I can hear you. Can you hear me? Yeah, can you hear me?
The voice is cracking a lot.
Okay, it's lagging. Just a moment. Can you hear me, Abdul?
Yes, yes, now I can hear you.
Clear. Okay, so can we write this minus under root minus 25 as a root 25 into root minus 1?
Yes, teacher.
That is, root 25 is a perfect square number which can be written just 5. And root minus 1, just now I have declared that is I, right?
I, the 5I.
Yeah. Okay, if we are having under root minus 81, what can be written, Abdul?
9I.
If we are having root minus root 3, what can be written?
Three I.
Root 3i. Okay, because for now it is
Okay.
not possible for us to take this number from the root sign. Okay, we are not able to take it out, right?
Okay.
So root 3 will remain as it is and we will be writing it in terms of I. Clear so far?
Yes, teacher.
Okay, so the in the beginning what I explained, that b square minus 4ac is smaller than 0. This is the case which is talking about the situation that roots are not real. When roots are not real, then what? This was beyond your scope in class 10. You just learn this is the situation which says roots are not real. Roots are not real, just that. Okay, and students never asked that if it is not real, then it is what? And it was beyond your scope as well at that time. Now, here I am telling you when roots are not real, then it is imaginary. Okay, example I have taken x square plus 1 is equals to 0. If we will take this 1 to the other side just for solving it, basic way I'm going to simplify. So will it be x square is equals to minus 1?
Yes.
Okay, and can you see x will be plus minus under root minus 1? Yes or no?
Okay. Teacher, why does this plus minus come?
When you are having x square is equals to 9, okay, x will be plus minus root 9, right? This plus minus comes due to the fact that there are two x values, plus 3 and minus 3. That means when we will do plus 3 square, then also we'll be getting positive 9. When
Okay,
we will
okay.
do minus 3 square, then also we'll be getting positive 9. So there are two possible answers. In till class 8 or 9, you were just seeing the positive answer, but in class 10 you got to know that no, we have to take plus minus sign because both the numbers is square. Okay, we will do squaring of plus 3, we will be getting positive 9. Even though we will do squaring of minus 3, we will be getting positive 9, right?
Yes.
Okay, this both the values are possible for x, hence we are taking both in consideration, right? So can you see the
Yes,
way
teacher.
we are dealing with that 9, same way we have to deal with this minus 1, right? Plus minus under root we have to put over here as well, right?
Yes, teacher.
And the moment we got root minus 1, we know this is related to the complex number chapter. This can be written as I. So the answer for x is plus minus I. One of the x value is plus I, another x value is minus I. I is imaginary unit. Clear? Iota. Is it clear, Abdul?
Yes, teacher.
Okay, so that's why this quadratic equation, this solving part and all, you have never done in the previous class. For the very first time, I'm showing you that when you will try solving, you may get negative inside the root. Before class 11, you have never seen a negative number inside the root. Okay, if you will recall, you have never ever seen such question which you were trying to solve and you ended up getting minus 2 or maybe minus 25. This is the first time you are seeing it, and we can write it in terms of I. Clear?
As soon as we see minus number inside the root, we should know it's an imaginary number.
Can you please repeat?
As soon as we see a minus number inside root, we should know it's an imaginary number.
Yeah, we can convert it in terms of I.
Okay.
Okay, making sense?
Yes, teacher.
Okay, so far any confusion, Abdul?
No, teacher.
Okay, today we have taken just the introduction. Okay, most of the time I was just taking the previous thing and was trying to connect it till here so that you will be able to develop the concept properly. We will be proceeding from here, but for now I want to take that assessment. Okay, so just a moment, let me share the screen. Okay, and yeah, if you have
Okay, teacher.
any confusion from here, please let me know.
Okay, teacher.
Can you see the screen?
Yes, teacher.
Yeah, there are 8 questions over here, mostly from class 10. Let's do number 1. How many multiple of 4 lie between 10 and 250? You have to use pen and paper for solving this question. And yeah, please solve it and tell me the answer directly.
Okay, teacher. Please just give me 5 minutes. I need to go down and come. Yes, I'll be back in 2 minutes.
Yeah, yeah, sure. Take your time. Are you there, Abdul? Yes, Abdul, are you there? Can you hear me, Abdul? Are you there?
How do you do the first question? Hello. Hello, can you hear me, teacher?
Yeah, are you there, Abdul?
Yes, teacher.
Okay, so we are running out of time now. You will start and you won't be able to cover it. It's completely fine. We can take it in the next class. Okay.
Okay, teacher.
So yeah, any confusion so far? Whatever we have discussed from there.
No, teacher. The chapter till now, no confusions.
Yeah, what you said.
Yeah, no confusions in the chapter.
Yeah, the complex number we have started, but not properly. Today I have just taken the introduction and the previous portion. Okay.
Okay, teacher.
Yeah, we can continue